All right, here is the second video for assignment number 2. This is day 6 of July 7th, or day 6 in our summer school. This is a work sample alert problem, so please make sure you get the right heading on there, show your work on the paper, and attach it to your Google Classroom assignment. That'd be great. So we're looking at 6.3 now. So 6.3 is right below 6.2. 6.3a, we're going to start our logarithm functions. So let me show you a little bit there. So I've got a little chart here for you that I wrote. So I rewrote number 1 up here, and I kind of let you know what everything means. So the little number, the base number, log base 2, it's in the equation, it's going to be the big number. The big number in a log is actually our answer, and the answer in our log is actually the exponent. So let me show you what I mean by that. If we take that into consideration and we take this problem and look down here, 1 second, there we go. We go down here to it, then you're going to take the base, is it going to be a 2? The exponent was the 3, and the answer is the 8. And that is true. 2 to the third power is 8. 2 times 2 times 2 is 8. So if we continue with that logic, the small number is a 7 equals the answer, and the 1 is the exponent, and 7 to the first power is 7. This last one, your small number is a 5, and then this 2 is your exponent, and the big number is your answer. So that works. I could have actually put 7 to the first power equals 7, and that might have been a little bit easier to understand. All right, so there's the first 3 for you. Now the second 3 are asking you to write them as a log. Okay, so remember the big number is our base. So log 4, and the answer is this big number, and the exponent is there. So that would be log of 4, base 4 log of 16 equals a 2, because 4 squared, if I took the 4 and I squared it with my exponent, that would equal 16 right there. So 4 squared would equal 16, kind of goes around there. Second one, so log of the fifth root, log of root 5 of 1 equals 0. And yes, 5 to the 0 power equals 1. So if you take 5 to the 0 power, it will equal 1, because any number to the 0 power is a 1. So anything to the 0 power is 1. So here we have log base 6, okay, to the 1/6, to the 1/6 equals -1. So if I put 6 to the negative first power, I am going to get a 1/6, because the negative power is going to move that 6 to the bottom. So that does work. Okay, the next ones are saying to evaluate. That means set it equal to x and solve it. So we set it equal to x and we want to solve it. So 2 is our base number. So 2, the x is our exponent, and the big number is our answer. So 2 to what power equals 16, and x has to be 4. Because 2 times 2 times 2 times 2, 4 times will get you 16. So you would have to multiply 2 times itself 4 times to get 16. Here we would put it equal to x again for number 8. And it would be 5 to the x power equals 125. And this x has got to be a 3. 5 to the third power is 125, because 5 times 5 is 25, times another 5 is the 125. Number 9, if we put it equal to x, you'll have 6 to the x power. Remember, it goes, the small number becomes big, and that's your power, and it equals the 6. And x has to equal 1 there because 6 to the first power would be the same as 6. Let's do numbers 10, 11, and 12. Leave it like that for you. Okay, so number 10, we'll look out over here. So we want to make it equal x. So we've got 5 to the x power equals 1/5. So that means we need the 5 to get to the bottom. We're going to have to put a negative exponent. So it's going to be -1. 5 to the negative power would move that 5 to the bottom, and you'd get a 1/5. Number 11 here, we'll squeeze it in, equals x. So it's going to be 9 to the x power equals 1. And I told you that any number to the 0 power equals 1. So that x is a 0. So this x was -1. This x was +1. This x was 3 up here. This x was 4 right there. Last one we'll do over here. So we wanted to set it to equal to x. So it's going to be 2 to what power equals 1/8. So we need an 8 to be on the bottom, so we know it's got to be a negative. And 2 to the third power is 8. 2 times 2 is 4 times 2 is 8. So you would need a third power and you would need a negative. So it's got to be -3. All right, the next ones are just asking us to evaluate it using a calculator. So let me zoom in a little bit. Let me go to the desmos.com/scientific calculator. That would be this one right there, /scientific. If you hit the function button, you get logs. So we want to go to a log of 5. So go back to the main and put a 5 in there. And you can close it off if you want to, and you're going to get 0.6989 or it's going to be approximately 0.7. Okay, so we'll just do an approximate symbol there. So you can see the approximate symbol, and we'll go 0.7. Now this is ln, that's a natural log. It's a little different function than a regular log. So let's see. ln is right there, and we want 14. Okay, so that's 2.64, we'll call it. 2.64. Again, it's just approximate. And we want the log of 1/4. So you could put log and you could put in 1/4. It'll give you a fraction. And you can see, or you can just put in 0.25. It'd also be the same as 1/4. And you'll see you get the same answer there. -0.602. So we'll just call it -0.6. Round it off. So this is approximately -0.6. So those are 3 just using the calculators. We'll skip 16. Let's go to 17. Simplify the expression. Okay, so what we want to do here is set it equal to a y value, because we already have x in the problem. And then we want to try to set it up like we normally would. So we would have okay, so the exponent is the answer. So this is the exponent is log 5 to the x. That's the answer, and it equals 5 log of the big number to the y. So you have log base 5 on both sides, so you would just say x equals y in that case. So that was 17. 18, we want to set this equal to y. And so let's see. 8 log 8, so there's our big number, so log 8, log base 8 to the y equals log base 8, the exponent is log base 8 to the 2x. So you got your log base 8 on both of them, so that means y equals 2x. It's just simplifying, you're not solving those. But you've got your log of the big number equals, or to the answer. Remember, the answer is always second, and then equals the exponent. And so the exponent, this exponent right here, is what it's equaling way over here. So it's the same formula as before. So let's see, we go to equals a y value here for 19. So you've got, this time they gave you the log as a big number. The other ones, the logs were exponents. This one, the log's not the exponent. So the base, so it's 4 to the y power equals the big number, which is 4 to the 3x. So since they're both the same base, again, y has to equal 3x. Just again, simplifying those. That's all you're doing on those. Okay, find the inverse of the function for the next ones. So find the inverse of these functions. Sorry about that. You guys couldn't see those that well, so I just put them back there for you. The inverse of the function is basically switching the x and the y values and then solving for y. So in other words, let's go 20 down here. You can see that. Right now, y equals 1.1x. So let's change it to x equals 1.1y. Okay, and then let's get y by itself. So let's change this to log 1.1. Remember, the big number is our base of our log to the x equals y. So now you've already got y by itself, so that's your inverse function. So you change again, number 21, you're going to change the x and the y. So you're going to put x equals 3 to the y and then write it as a log. So we're going to get log base 3, because log of the big number, to the x, which was your answer, x was the answer, equals the exponent, which is y. So we got y by itself already. So that's your inverse function right there. And let's see, I think that'll be enough. We'll skip the rest of those. So when you get to when you get to your puzzle, you should be able to do all those now. You don't need the inverse functions on any of those. So we don't really have to do any more of those inverses, but here are the ones you're going to do on your puzzle. Rewrite in exponential form, rewrite in log form, and then evaluate. So set them equal to x, and then solve it. So that should be enough to get you through 6.3.